So let's start with caramelization.
Sobre una crema, penso que té un nom, que és una crema catalana. Per tant, necessitarem la crema feta, reposada, ja seca, amb aquest petit tel que ha fet a sobre, que també ens ajudarà a posar-hi la càrrega de sucre per fer aquest cristall que volem formar de cop i volta. Hem de ser un pèl generosos per poder-lo fer, però sí que l'hem d'escampar d'una manera uniforme per poder-hi aplicar la pala. La pala que ha de ser un roig roent, a una temperatura altíssima. Per tant, la pala s'aplica sobre la crema. Per fer-hi aquest punt cremat, li dona aquest efecte. Ara, evidentment, no en seria tova, però instantàniament queda sòlida, queda líquida. Podríem, si us sembla, mostrar com trenca. No sé si us interessa. Bé, aquest és aquest efecte de caramelització, però al moment, per assolir aquest so... Aquest cristall fet del bull. M'agradaria que la tastis.
Okay, thank you. I love Crema Catalana.
Molt bé.
Thank you.
Gràcies.
Thank you. So caramelization is just what happens when you heat sugar, white table sugar. So sugar is just a sucrose molecule, and a sucrose is made of fructose and glucose. And so the first thing that happens when we apply heat is that these two molecules fall apart into glucose and fructose. And so here is sort of what these ring structures would look at. And then these ring structures just sort of explode into a wide array of other small molecules. And all of these molecules have different flavors and different smells. And typically in caramelization, the flavors that we're talking about are these sort of sherry, buttery, nutty flavors. And this happens at temperatures of about 165 degrees Celsius or higher. So if we were to take these flavors and kind of put them on what we call a flavor wheel, which is what wine tasters or tasters in general would use when they would try to sort of guide their pinpointing what a flavor is. And here's a flavor wheel with all of the different flavors, everything from earthy to nutty to fruity to flowery. And so caramelization kind of creates these particular flavors that are sort of caramelly and nutty buttery. And so now keep this in mind, because now we're going to move on to Maillard reactions and see what kinds of flavors those create. Maillard reactions, in contrast to caramelization reactions, involve the reaction between sugars and amino acids, and these typically take place at temperatures above 120 degrees Celsius. And so what happens here is that if you, for example, just take milk and heat it, there's going to be sugars in the milk and there's going to be proteins in the milk, amino acids, and the sugars are going to react with the amino acids and create these sort of browner compounds that have nutty flavors. And so you've probably had this, if you've ever had dulce de leche, you've had this exact same thing. And there are a lot of desserts and a lot of sauces that sort of build on this concept of just heating milk and creating these flavors. And so there are many different kinds of amino acids. There's about 20 amino acids, and each of them, the first step would be that the glucose reacts with the amino group on any of the amino acids. And so the amino group is a nucleophile, if you think back to chemistry, and the nucleophile is going to attack the carbon on the glucose here. And this is then going to form a bond, and this is kind of the first step in the Maillard reactions. And after this, there is a whole, again, just an array of different reactions that can happen. The molecule falls apart, it reacts again, it reacts with each other, with other glucoses, with other amino acids, but this is the first step. And so you can imagine then that if there is 20 amino acids, and this is the first step, you can just imagine that there is just a lot of different molecules that can be created, even with this just being the first step. The characteristic feature of Maillard products is that they often contain sulfur and nitrogen, which comes from the amino acids in the protein. And sulfur and protein often contributes these kind of meaty, earthy flavors that we associate with when we cook a steak, and there's sort of this earthy, meaty flavor. And this also then contributes to a lot of the other sort of non-distinct flavors that are very different from the flavors that we get in caramelization. Another feature that make Maillard reactions reactions, especially interesting from a chemical perspective, is that they're often exothermic reactions. Exothermic reactions produce heat as they happen. And so as Maillard reactions start to happen, they produce heat, and this then leads to more reactions happening. And so this speeds up. And you may have experienced this actually if you've ever made toast. So sometimes you may have experienced that you make toast and you wait and wait and it's not done and it's not done, and then suddenly it's done, and then it's done, and then it's overdone. And it just happened very, very quickly. Maillard reactions, of course, are not only in baking, they're basically everywhere around us. So here's just some examples. Everything from coffee to popcorn to champagne to a nice cured ham are all places where Maillard reactions have taken place. And in some of these cases, there hasn't even been an addition of heat. So in champagne, for example, the reaction is allowed to take place over so long that the reactions take place anyway, even though there is no input of heat. But all of these sort of earthy flavors that you get in a champagne or in mead, they're all also due to Maillard reactions.